Hey KJ, how's it going?
Pretty good. How are you, David?
Good. What are you doing?
Just some physics homework.
Oh, good old physics, you know. For lab this week, I had to create a bike generator. You wanna go see it?
Yeah, sure.
Let's go! This is my board. Okay, so this is how it works. We decided to put 4 light bulbs. 1, 2, 3, 4. These are the sets. We have a voltmeter, which records the voltage, ammeter, which records the current, an inlet, an outlet, 2 different switches, 3 different switches. This controls these light bulbs, this controls these light bulbs, and this controls the outlet. You get it?
Yeah.
Let me tell you about the art. Okay, so let me tell you about how we wired it. This translates to this. This is our power source, in which we use our little electric motor to power this circuit, right? Because you need energy to power your stuff, man. As we have connected in series, that means next to it without having a current splitting. We have an ammeter to record the voltage. And then in parallel, we have these 1, 2, 3, 4 sets of things connected. The first set, well, the first 2 sets are 2 light bulbs connected to a switch. These are all in series to each other, but parallel to the entire system. These want to be in series with this switch because if we want one switch to control these 2 at the same time, it needs to be in series. Because if I'm the current and I'm coming this way, and I want to go in here, if this is cut, these both won't illuminate, but if it's closed, these both will. And so that way we can control both at the same time. Same for this, and this one, this switch will control the connection of this output. And the voltmeter all the way at the top is still in parallel, and that will tell us about our voltage.
Why do you connect things in series and in parallel?
Well, like I told you before, KJ, great question. If I wanted to control these 2 light bulbs, I can do it at the same time by using this one switch alone without affecting the rest of the things in the system. It's like the things in your house. If I wanted to turn off this light without turning off the light in the kitchen, I can turn it off by itself.
So how does this power source work, David?
Okay, so in order to have a motor create current via movement, we need to get a coil of wire of conductive metal like this. And once we have a coil, this coil of wire, if we put in a magnetic field into it, this group of wire will cause a magnetic field of its own. Okay, so we have our local wire, and if we put a magnetic field into it, that's going to change something called the flux, and the flux is basically just code for how much magnetic field is going into this area. And whenever we have a change in flux, there will be an induced current in this wire. And so if we have a system in which our coil or our magnet moves, the flux through this loop of wire will change if the area changes or if the amount of the magnetic field changes. And this will create a current. So Ohm's law tells us, speak English, fellas, that if you have a voltage across a resistance, that would give us a current. And so we see differences in when we pedal slow than when we pedal fast. Our energy board.
Cool. Yeah. So if you were to use that formula, we can figure out the resistance of the light bulb.
Yes, we could.
And we can figure out the different resistance if we have one set of light bulbs on compared to 2 sets of light bulbs on.
So then tell me what this means, because I didn't really get it when I did it.
Wow, since the two different sets are wired in parallel, that means that the resistance decreases when both sets are turned on because there's more current to be dispersed among the different light bulbs.
Yeah, then why does the voltage not change?
Because that's the power supply.
Tell me about the voltage.
Well, according to Faraday's law, you have a change in flux over change in time. So when you increase the flux into the power supply, you get an increased voltage. So pedaling faster will increase the flux and therefore increase the voltage. And since the resistance is the same across all the light bulbs, it will increase the current according to Ohm's law. What's the difference?
Oh, bueno, déjame decirte que la diferencia, si tienes el mismo nivel de voltaje en el sistema, la única diferencia entre los dos focos es que el foco viejo tiene más resistencia en comparación del foco nuevo. Y entonces, si refiriéndonos a Ohm's law, si bajamos el nivel de resistencia, el nivel de corriente sube. Así que lo que significa es que para una resistencia, para un foco con más resistencia, ocupamos más corriente para poder dar el mismo brillo. En comparación con este que tiene menos resistencia, podemos usar un poco menos de corriente para que nos resulte el mismo nivel de brillo. Slow pedaling, slow. So much eye contact.
Oh, that's so
I love the